NASA's space shuttles are some of the most high-tech and complex vehicles ever built, but they couldn't fly without the help of a much older technology, the railroad. This is no ordinary train. It's the NASA Railroad at Kennedy Space Center in Florida. It carries extremely dangerous freight, one of national importance.
It's not something to just kind of sneeze about, you know. When we're hauling in, we're hauling 4 to 5 million pounds of explosives.
One shuttle solid rocket booster contains 4 motor segments packed with a hard, rubbery, volatile solid propellant. Every space shuttle launches with 2 boosters, which give the vehicle the extra thrust it needs during the first 2 minutes of the climb to orbit. The large, heavy motor segments have to take a week-long cross-country train ride from the ATK manufacturing plant in Utah to NASA's Kennedy Space Center in Florida.
In shuttle, of course, with the segments, it is absolutely essential because you're looking at an average of approximately 150 tons per segment, and with 8 of them per launch. There really isn't any other better way to get them here from Utah. It's just an essential lifeline is what it boils down to.
Today, this important but hazardous job is handled by URS Corporation engineers and mechanics in the railroad shop. The 11-member team takes care of all the rolling stock and the track system, including electrical work, mechanics, painting, welding, and even fabrication. That expertise is essential when it comes to handling the solid rocket booster segments, which travel to Kennedy on cradles inside custom-built rail cars. During the trip to Florida, the segments are handed off from rail company to rail company, with the final handoff at NASA's J.J. Railroad Yard north of Titusville, Florida. The Florida East Coast Railway, or FEC, delivers the segments to J.J., and that's when Kennedy's railroad team takes charge. After a thorough inspection, empty spacer cars are added to prepare the train for the trip across the Indian River to Kennedy.
The main purpose for us is to distribute the weight on our bridge coming across the Indian River. If you have all the heavy cars tied together, that puts a strain on the bridge, so try and separate the weight.
The Kennedy rails can handle speeds of up to 60 miles an hour, just like FEC's mainline track. But because of the heavy and volatile cargo, the top speed here is only 25 miles an hour, and the trains typically move slower than that. All the work is done by a 1,500 horsepower locomotive known as the EMD SW-1500. NASA has 3 of these workhorses. They were built by General Motors between 1968 and 1970 and put to work for the space agency when shuttle loads demanded a lot more horsepower.
They do have a lot of backbone. And again, when we bring in the segments and the spacer cars, you know, we got probably close to 4.5 to 5 million pounds that we pull with one motor.
Once the train arrives north of the Space Center, the spacer cars are removed and taken back to the rail yard. The booster cars are kept at suspect siding, an isolated staging area near the shuttle runway, until they go to the rotation, processing, and surge facility to start final launch preparations. When the boosters are recovered after launch, the same team loads up the spent segments and sends them back to Utah.
Got a great track record, and it's basically a pretty simple process, you know, from all the way from Utah all the way to here to getting it on the launch pad, and the system has worked great.
Kennedy's rail system was activated in 1963 to bring in construction materials for the growing Space Center as new facilities were built for the Apollo program. But throughout the years, the Florida climate took its toll, and hauling shuttle segments presented unique challenges of their own.
Well, fast forward 20 years, and the Space Shuttle program was starting, and we were looking at freight cars that were somewhat longer and a lot heavier and had a high center of gravity as well.
FEC was paid to upgrade the aging system with heavier rail, welded joints, and concrete cross ties. Along with rolling stock standards like hopper cars and gondola cars, Kennedy also has some cars that were modified or even designed here. In fact, Hoffman himself designed the Booster Structures car.
It's a custom-built car. It's a concept I came up with to improve on the delivery of, or the movement of the solid rocket booster aft skirts, the forward skirts, and the frustums.
Many other commodities have traveled these rails, such as nitrogen tetroxide rocket propellant, Air Force Titan rockets, Navy Trident missiles, and the shuttle-derived booster segments for the Ares 1X test flight.
It's not just moving segments. We've done so much more. We've rebuilt the Air Force locomotives. We've built rail cars. We've done painting. I mean, this locomotive here, you can see how much better it looks than the other two and everything. So we're a pretty diverse group and we stay busy.
The result is a vital and successful rail line that has stood the test of time. In May 2010, the last load of shuttle solid rocket booster segments came to Kennedy.
For the most part, it's you know, it's kind of like any other railroad, so to speak. We don't run the speeds, but the things that we do and have to do when we're loading and unloading, you know, demands your attention, demands respect.
The NASA Railroad at Kennedy Space Center has played a quiet but critical role in the Space Shuttle program, and the hardworking team hopes to put its talents to use on future spaceflight endeavors.